All right. So I saw like a banner on there. I was like, what's going on? I have to put it in. I usually put it in like airplane mode, and I forgot to do that. So sorry. All right. So it's a hormone, and as I was just about ready to say, that humans, when we remember hormones in humans, are produced by one part of the body and go to another part of the body and cause a change to happen. And that happens in plants too. So in plants, it's in one part of the plant the hormone is produced, goes to another part of the plant and triggers a change to happen. So when it says that this elongation that triggers the bending, that elongation is a hormone that's produced by the tip and moves and causes the shaded side of the plant to become elongated. So this is his experiment in trying to figure this out. So what this picture is he cut the tip off. So he chopped the tip off, and he put it says tip separated by a gelatin block. So gelatin block, this is porous. All right, so gelatin is what Jell-O is made from, right? And so it's a porous block, and then he put the block there and put the tip right back on. And the reason why the porous part is important is because he found that the hormone that's produced by the tip can actually get through the porous gelatin block and communicate with the rest of the plant, and the light bends. Versus if he did the exact same thing, and here's the hormone produced by the tip of the plant here, if he did the exact same thing here, except instead of using a gelatin block, he used mica, which is non-porous. So therefore the hormone can't get through there. So therefore the hormone stays something like this here. It tries to get through, but can't. It stays there. And therefore there's no communication between the tip of the plant to the rest of the plant, and the plant stays straight. So this helped to show that there is some kind of chemical messenger, some kind of hormone that's triggering this. So to add to this, we have Fritz Wendt. What he did is he figured out what hormone it was. He extracted the chemical messenger for phototropism, which is auxin. So this is the hormone. By modifying Peter Boysen-Jensen's experiment. So this is his experiment. All right. Again, on this one, I'll give you a second if you want to jot this down. It's also in our book. This is figure 39.6 as well. Okay, so let's look at the different scenarios here. what they did, all right, here's the control. So they cut, all of these had the tip cut off. So let's look at the control is just with the tip cut off, and as we learned from the previous experiment is that the bending doesn't occur. And they're assuming remember the tip, they were kind of proving what the chemical is that causes this to happen. So without the tip there, it doesn't bend, regardless if there's light or not. Then here's another part of the control. Now notice here that the tip is cut off, and they put this block on the top, this agar block. So it's kind of like agar that we grew the bacteria on. And it says agar block lacking the chemical. So therefore, what was the chemical? The chemical was auxin. So it lacks the chemical. So it has no effect. And so they just put this on here, and it grows straight up. Then what they did for the other three is they took an agar block, kind of soaked in the chemical auxin, the hormone. And how they did that, so up here, this is kind of the production of the agar soaked block. They took a tip from a plant, and the plant makes the chemical auxin, and they stuck it on top of an agar block. And so what happened is that hormone diffused into the agar. So that's what we're seeing here. So now you have a block that has this hormone, this plant hormone in it, and they put the block on top of the plant that had, remember this is the dotted line, this is how tall the plant was when they cut off the tip. So therefore they cut off the tip, and they all have the same starting point. So what happens here is this block that has the hormone auxin, that auxin diffuses down the plant. And therefore, the auxin is in equal concentration throughout the whole block, and so therefore is in equal concentration along the whole plant, and the plant grows straight up. It's not bending either way. So then, what they did is they took part of the plant, the plant with the tip cut off, and instead of putting the agar block soaked with auxin on the whole tip, they only put it on the right-hand side. So on this one here, this right here, only the right-hand side gets the chemical auxin. So that's because the block is only on the right-hand side. So that's the offset the block. And so therefore the chemical goes down only on the right-hand side. Notice that the plant, it starts to bend. We look over here, they did the exact same thing except they put the block on the right-hand side, or the left-hand side. So this one, only left side gets the auxin. And notice that triggers the bending in the opposite direction. So what would you say the hormone auxin triggers to happen? Remember, a chemical is, a hormone is something that's produced in one part of the organism, goes to another part of the organism, and triggers a change to happen. So the auxin is made in the tip, all right? So these blocks are kind of simulating the tip. The auxin is made in the tip. It diffuses down the stem and causes a change to happen. What does the auxin trigger to happen? More specifically than bending. Bending is a side effect based upon what is actually physically happening to the plant. Kelly? The cells are elongating. So here on the side that's getting the auxin, the cells are elongating, and so remember the cells, when the cells elongate, it causes the bending. On this side here, this cells are elongating, and it's caused the bending this way. And so that's why you get it to the left or the right based upon that. So this was bending is happening without sunlight. So therefore, with sunlight, which side for this one, would the sun be coming in? If this was happening in the sun would be coming in from the left, right? And so therefore, the auxin is being produced only on the shaded side. That's why the elongation occurs only on the shaded side. So let's pull it all together. Let's go back to the first page with the original picture. This one. Original picture here. What? So we said that the light is bending, or the light is bending. The plant is bending towards the light, and so now that we know what we know, what would be the first step in this? What happens? The light. What part hits the plant? What part of the plant is important that it hits? The tip. So I'm going to write here some things here. So the light hits tip of plant. What does that happen? What happens as a result of that? What is the tip going to do? Produces auxin. Does it produce auxin equally on all sides? No, it produces auxin on the shaded side. I'll just put the two here. Sorry, not plant. Sorry, I want to do tip. Tip produces auxin on shaded side. Does the auxin stay in the tip? No, the auxin does what? Auxin diffuses down shaded side. What does the auxin cause to happen on the shaded side? Cells elongate. On the shaded side, which then causes elongation, or bending. And so that is an example of a physiological response in a plant due to environmental cues. Okay? All right. We're going to stop, I think. All right, so there'll be two parts to this video.